Hello, welcome to Campus Papers. This is IGCSE Chemistry, Paper 4, Variant 2, February-March 2023. This is Part 1, covering questions 1 to 3. Let's begin. Question 1. This question is about gases found in clean, dry air and gases found in polluted air. Name one gas found in clean, dry air which contributes to global warming. And the name of that gas will be carbon dioxide. Carbon dioxide can be found in clean, dry air and also is a greenhouse gas. That is why it is the correct answer. Next question. State the percentage of nitrogen in clean, dry air. The percentage of nitrogen in clean, dry air is 78%. Next question. Name the substance used to remove sulfur dioxide in flue gas desulfurization. The name of the substance is calcium oxide. Next question. Nitrogen dioxide is formed in car engines. Name the equipment in a car exhaust used to remove the nitrogen dioxide formed in car engines. Now, this is catalytic converter. The catalytic converter used to change carbon monoxide to carbon dioxide so that a less dangerous gas will be produced. So carbon monoxide is more dangerous than carbon dioxide. So instead of carbon monoxide to produce, carbon dioxide will be produced. That is why we call it catalytic converter. Next question. All gases diffuse. Choose from the list of the formula the gas which diffuse most quickly. Draw a circle around your answer. The gas that will diffuse most quickly here will be the one with the lowest relative molecular mass. So that means in order to answer this question, we need to calculate the relative molecular mass of each of these gases. So let's start with carbon monoxide. How do we calculate the relative molecular mass? We calculate the relative molecular mass by adding the relative atomic mass of each element in each gases. So let's start with carbon monoxide gas. We have one carbon and one oxygen. So you check your periodic table, the relative atomic mass of carbon is 12. So therefore, the relative molecular mass of carbon monoxide is going to be 12. If you check your periodic table, you see that oxygen is 16 plus 16, that will be 28. Next is carbon dioxide. Relative atomic mass of carbon is 12. Oxygen is 16. So we have two oxygen, so it's going to be 16 times 2, which is 32. So everything will now be 44. Next is methane. We have one carbon, which is 12. We have four hydrogen. Relative atomic mass of hydrogen is 1, so it's going to be 1 multiplied by 4, which is 4. So 12 plus 4 is 16. Next is nitrogen. Relative atomic mass of nitrogen is 14. Oxygen is 16, and we have 2 of it, so 16 multiplied by 2 is 32. So it will be 14 plus 32, which is 46. Next is sulfur dioxide. Sulfur is 32 plus oxygen 16. 16 times 2 is 32. So 32 plus 32 is 64. So from this, you see that methane has the lowest relative molecular mass. So therefore, methane will be the gas that will diffuse most quickly. So our answer therefore is methane. So we circle it. So that will be our answer. So explain your answer. So we have to give reason. We have already started the reason already. It has the lowest relative molecular mass. So that's the reason why it is the correct answer. Next question. State one adverse effect of carbon monoxide on human health. So we have many effects. You could choose any one. So you can say it is toxic, or you could also say reduces oxygen transport in the blood. So like I said, we have many adverse effects of carbon monoxide. You just need to mention one. Next question. Carbon dioxide is a reactant in photosynthesis. Name the two products of photosynthesis. So the two products of photosynthesis are glucose and oxygen. Next question. Complete the dot and cross diagram in figure 1.1 for a molecule of carbon dioxide. Outer shell electrons only. So take note of that. That to show outer shell electrons only. So let's complete the diagram. Now, please take note that we have to complete the dot and cross. That means everything. Okay. So first thing we'll do, writing the dot and cross diagram for this is to write the electronic configuration. So for oxygen, the atomic number of oxygen for our periodic table is 8. So that means the number of electrons will also be 8 because atomic number is the same thing as number of proton, and number of proton is equal to the number of electrons for a neutral atom. So we have 8 electrons, so the electronic configuration is going to be 2 6. Then for this, oxygen is the same thing, so it's going to also be 2 6. Then for our carbon, we check the atomic number of carbon. Atomic number of carbon is 6. So since the atomic number is 6, our electronic configuration for carbon is going to be 2 4. So now if you look at this, oxygen needs 2 electrons to complete its shell. This oxygen also needs 2 electrons to complete its shell. And you must take note that the number of electrons atoms need to complete their shell is the number of electrons they are sharing. And two atoms that are bonded by covalent bond, they share equal number of electrons, at least at this level. Now, that means that this oxygen is going to give 2 electrons, and this carbon will reciprocate by giving 2 electrons also. So we can assign dot to oxygen and cross to carbon. So that means from this oxygen, we have 2 electrons. So carbon will reciprocate by giving 2 electrons also, but we are giving this one cross. Here it is the same thing because it's between carbon and oxygen also. So our oxygen brings 2 and then carbon also brings 2. So if you notice that carbon has given out all the electrons it has in this outer shell, to this side, to this side. So it is gone. So that means the outer shell is complete. We are not adding anything here. And besides, if you count the number of electrons that it has, is 8. 1, 2, 3, 4, 5, 6, 7, 8. So it is complete. Mind you that in covalent bonding, the number of electrons they are sharing belongs to each of them. They are sharing it. So it belongs to the carbon, it also belongs to the oxygen. Now, if you look at the oxygen has 6 electrons in the outer shell, but it gave out only 2. That means we have 4 more that is not part of this bonding. So those 4 electrons, you write them here on this oxygen, and then likewise here, because since they are oxygen and oxygen, now this is the complete dot and cross diagram for carbon dioxide. Now if you look at it, you realize that all the atoms are complete. Their outer shell is complete, having 8 electrons in their outer shell. So this is the complete dot and cross diagram for carbon dioxide. Now if you look at it, oxygen is complete, having 8 electrons in the outer shell. This oxygen also has 8 electrons, and then carbon also has 8 electrons. Question 2. Lithium, sodium, and potassium are group 1 elements. Name the type of bonding in these elements. And the type of bonding in metals is metallic bonding. Because lithium, sodium, potassium as group 1 element, all of them are metals. The type of bonding they have is metallic bond. Please don't make mistake of writing ionic bond. Ionic bond is between metal and a non-metal. Question B. Sodium reacts with cold water to form hydrogen gas and a gas of a strong alkali. Say the test for hydrogen gas. So we have test, we have positive result. So how do we test for hydrogen gas? So we test for hydrogen gas using lighted splint. If it is positive, a squeaky pop sound will be released. Next question. Suggest the pH of a solution of a strong alkali. So strong alkali will have a pH of 14. Next question. Name a substance which can be used to confirm the pH of a solution of a strong alkali. The substance to confirm pH is universal indicator. Next question. Write the symbol equation for the reaction between sodium and cold water. Include state symbols. So, in order to write symbol equation, you need to know the symbol of the compound given to you or the element given to you. So, in this case, we have sodium. The symbol for sodium is Na plus cold water. So cold water, the symbol of water is H2O, whether it is cold or not. So what will be the product? Sodium plus water will give us alkali and hydrogen gas. Whenever a metal reacts with water, an alkali and hydrogen gas are formed. So in this case, the alkali that will be formed will be sodium hydroxide, and then gas also will be produced. And don't forget that I said we should include state symbols. So don't forget this instruction, very important. So sodium is a metal, so that means it's a solid state. So our water is not a vapor water, so it's going to be liquid. And sodium hydroxide, it is dissolved in water. It is from reaction of sodium and water that is gotten. So that means it's going to be aqueous. Aqueous simply means water is used as a solvent for the formation of that solution. So same thing happened here. We use water with sodium to get sodium hydroxide. So therefore the state symbol is aqueous. And of course, our hydrogen is a gas, so we're going to put our gas. And then it is not over. You need to check that your equation is balanced. How do we do that? We count the number of atoms on the right and the number of atoms on the left. So let's start from the reactant, which is the left. We have 1 sodium here, 1 sodium here. Then we have 2 hydrogen here, but here we have 3 hydrogen. So we need to make them equal. Don't forget, when you're balancing chemical equation, you write your number as coefficient. So that means the number we're adding is going to be here, or here, or here. So we have 2 here. Since we have written 2 here, that means our sodium is 2. So we need to add 2 here also. Then our hydrogen is 4 here. 2 times 1 is 2 plus 2, 4. But here the hydrogen is 2, so we add 2 here to make it 4. So now our equation is balanced. We've written the state symbols, so you can definitely get your 3 marks for this question. Next question. Lithium has 2 naturally occurring types of atoms, lithium 6 and lithium 7. State the name given to atoms of the same element with different nucleon number. The answer is simply isotopes. Complete table 2.1 to show the number of protons, neutrons, and electrons in the atom and ion of lithium shown. So number of protons. How do we know the number of protons of lithium? We use our periodic table. The number of protons is the same thing as the atomic number. So we check the atomic number of lithium. This is lithium. The atomic number is 3. That means the number of protons is also 3. Next is number of neutrons. In order to get our number of neutrons, we subtract the protons from the mass number. Now, what is the mass number? Mass number is the sum of the protons and neutrons in the nucleus of an atom. Now, the nucleus of the atom contains the proton and the neutron. So the sum of the particles of the protons and neutrons will give us the mass number. And since we know our protons to be 3, that means we can get the number of neutrons by subtracting the number of protons from the mass number. So here for this lithium, its mass number is 6. So the number of neutrons is going to be 6 minus 3, which is equal to 3. The next is number of electrons. For a neutral atom, what do we mean by neutral atom? An atom that has not lost or gained an electron. An atom that doesn't have plus or minus sign on it is a neutral atom. For neutral atom, the number of protons is equal to the number of electrons. And that is why it is even neutral, because the protons are positively charged and the electrons are negatively charged. So they cancel out each other. So therefore, our answer here is 3 also. Next, we move to this lithium. For this lithium, the number of protons is still going to be 3 because even though they are isotopes, but they have the same number of protons. The atomic number is the same lithium. Therefore, the answer is 3. Then neutrons, number of neutrons, same thing will be number of protons subtracted from mass number. So here our mass number is 7. Mistake that students usually do make here is to use their periodic table to get the mass number for both isotopes. If you go to the periodic table, you realize that the mass number of neutrons is 7 and not 6. So but because it's isotope, they have different number of neutrons. So we have to stick with the mass number given to you in the question. So this is going to be 7 minus 3, which is 4. And then for the number of electrons, it's going to be changed because this is a lithium ion. It's not a lithium atom. It's not neutral, but it has a charge. That means this positive is indicating that it has lost 1 electron. That's what that positive means. I mean, it has more proton than electron. Remember that your proton is positively charged. So therefore, our number of electrons is going to be 2 because the lithium lost an electron. So therefore, number of electrons for lithium ion is going to be 2. Next question. Table 2.2 shows the relative abundance of two naturally occurring atoms of lithium. Look at the table here, 2.2. Calculate the relative atomic mass of lithium to 1 decimal place. So take note of this. We are calculating to 1 decimal place. And to calculate the relative atomic mass of lithium, we multiply the mass number by the percentage, and then we add it and divide it by 100. So let's do that quickly. So this is how it's going to be. 6 multiplied by 10 plus 7 multiplied by 19 divided by 100. When you put your calculator, the answer is going to be 6.9. Remember, we are told to leave it in 1 decimal place, so don't approximate it to 7. Leave it as 6.9. Next, potassium oxide is an ionic compound. Complete figure 2.1 to show the electronic configuration of the ions in potassium oxide. Show the charges on the ions. So we have 2 tasks here, is to complete the diagram and then we show the charges. So how do we do that? As usual, first thing you do is to write the electronic structure of the element involved in that compound. So we have potassium. Check our periodic table. Potassium is here and the number of protons is 19, meaning that it has 19 electrons also, because the number of electrons is equal to the number of protons for a neutral atom. So this is 19. So the electronic structure is 2881. And of course, we have oxygen. Oxygen is 8. You can confirm from your periodic table. So the electronic structure is going to be, so this is another potassium. So the same thing with this potassium, 2881. So this is an ionic bond. That means there's transfer of electron. This potassium is a metal. It will give out 1 electron to become stable. Once it gives out 1 electron, this one becomes positively charged, meaning that it has more protons than electrons because it has lost 1 electron. Now, if you look at the structure, we check whether it's complete. This is 2, which is the first shell. We have it 1, 2. In the second shell, we have 8 electrons. So that means we need to add another shell to put the next electrons here. So this is going to be, and then we put the 8 electrons. So this will be the complete diagram for potassium. Then for oxygen, it's going to gain 2 electrons to complete the shell, 1 from this potassium and 1 from this potassium. So it will become 2, 8. So that means we are adding another shell. So this is going to be, so we add the 8 electrons, 6 from the oxygen, and then 2 that it gained from the potassium. So we start by writing the 6 electron of the oxygen using cross because we have crosses, so don't use dots. So this is the 6 electron. Then it gains 2 electrons from the potassium. The potassium will have dots. So this is the first electron from the first potassium. then the second electron from the second potassium. So next is the charge. It has gained 2 electrons. The charge of electron is negative, so it gains 2 electrons, so it's going to be 2 minus. Then this potassium is the same with this potassium, so we are repeating everything that we did to this potassium on this one. So this is going to be, so this is the complete electronic configuration for the ions in potassium oxide. Question 3. The Haber process is used to manufacture ammonia. State the main source of each gas used in the Haber process. So the two gases used is nitrogen and hydrogen. So the nitrogen is gotten from air and the hydrogen from methane. Next question. The equation for the Haber process is shown. This is it. It's a reversible reaction. And we have our enthalpy change here. We need to underline this. Take note of it. The reaction is reversible. The full reaction is exothermic. State what is meant by the symbol delta H. I've already said it. The symbol is enthalpy change. Next question. The enthalpy change for the forward reaction is minus 92 kilojoule per mole. State why this value shows that the forward reaction is exothermic. So the reason why the value shows that the forward reaction is exothermic is because the enthalpy change is negative. If the enthalpy change is negative, that means the reaction is exothermic, or if it's positive, that means it is endothermic. Next question. State the typical conditions and name the catalyst used in the Haber process. So we have our temperature. So the temperature is 450 degrees Celsius, and then the pressure is 20,000 kPa. The catalyst is iron. So please take note of the pressure. It's kPa, not atmosphere. So do not make the mistake of writing the pressure in atmosphere. Next question. Complete table 3.1 to show the effect, if any, when the typical condition in the Haber process are changed. Use only the words increases, decreases, or no change. So let's look at that. Change to typical conditions. Temperature increases. When temperature increases, the rate of the forward reaction will also increase because there will be more energy, there will be more pollution. Okay. And next is effect on the concentration of ammonia at the equilibrium. Now, in an equilibrium reaction, whenever there is a change, the equilibrium will shift to oppose the change in that equilibrium. So now, this question, we are asked, what is the effect on the concentration of ammonia when temperature is increased? Now, you must know that when temperature is increased, the equilibrium will shift to the endothermic side. I remember that endothermic absorbs thermal energy. So when we increase temperature, the equilibrium will move to the endo side so that it will absorb that thermal energy that you are adding in order to oppose the change in that equilibrium. So now, since the forward reaction is exothermic, that means the reverse reaction or the backward reaction is endothermic. And if the backward reaction is endothermic, that means if we increase the temperature, the equilibrium will move to this side, which is the reverse reaction. And by moving to this side, that means the concentration of the ammonia will decrease. So therefore, what you're going to write here is decreases. Next is pressure decreases. When there's decrease in pressure, the particles will be far apart from each other. And since the particles are far apart from each other, that means there will not be much collision. And if there is decrease in collision, then the rate of reaction also will decrease. So therefore, the effect on the rate of reaction is going to be decreases. Now, what will be the effect on the equilibrium? Now, for equilibrium, when you decrease pressure, the equilibrium will move to the side with more gas molecules because you are making the particles to be far from each other. So the equilibrium will tend to shift to the side that there are more particles. So how do we know which side? We calculate that. So this is the reactant. We have one nitrogen molecule. The number of the molecule is the coefficient. So 1 mole of the gas plus 3 moles of hydrogen is going to give us 4. Then on this side, we have only 2 moles of ammonia. So when the pressure is decreased, the equilibrium will shift to the side with more gas molecules, which is reverse reaction or backward reaction. So, and if it is moving on the reverse, that means the concentration of ammonia will decrease. And lastly, for catalyst is removed, the rate of reaction will decrease because catalyst speed up the reaction. Effect on the concentration of ammonia at the equilibrium. Catalyst does not have effect on the position of the equilibrium. So therefore, our answer is going to be no change. So this is the answer. Make sure you use the words decreases, increases, and no change. Don't use another word. Next question. Explain in terms of collision theory why increasing the temperature increases the rate of the reaction. So this is simple. The reason is kinetic energy will increase and then the frequency of collision will also increase. Then that means that the particles we have more energy greater than or equal to activation energy, thereby speeding up the reaction rate. So please note that it is a 3-mark question. We try as much as possible to provide 3 points. Next question. Ammonia reacts with an acid to form ammonium sulfate. State the formula of the acid used. How do we know the acid that is used? From the name, you can know the acid that is used. Look at it here, ammonium sulfate. So that means the acid that was used is sulfuric acid. State one use of ammonium sulfate. Ammonium sulfate is used in making fertilizer. Next question. Calculate the percentage composition by mass of nitrogen in ammonium sulfate. And in order to do that, it means that we are going to divide the relative atomic mass of nitrogen by the relative atomic mass of ammonium sulfate multiplied by 100. So this is going to be, so we check how many nitrogen do we have here. We have 2 nitrogen. How do I know this? Small 2 is for everything inside the bracket. So we have 2 nitrogen. So let's check our periodic table. Nitrogen is 14. So it's going to be 2 multiplied by 14, which is 28. And divide by the relative atomic mass of everything. So how do we calculate that? We have 2 nitrogen. So a nitrogen is 14. It's going to be 14 multiplied by 2, which is 28. Hydrogen, we have 4 here. 4 times 2 is 8. Relative atomic mass of hydrogen is 1. So 1 times 8 is 8. Our sulfur is 32. You can confirm that from the periodic table. And oxygen is 16. And we have 4 of it. So it's going to be 4 multiplied by 16. So you multiply by 100. When you sum everything, this is going to give us 28 divided by 132 multiplied by 100. This will now be equal to 21.2%. That's the end of part 1, covering question 1 to 3. I'll see you in part 2. Don't forget to like, share, and subscribe.